Hello everyone, um, I'm against, and today I'm gonna to help you develop own software in own form. So first of all, here I have developed several software like my Icoform, my Simple Form, my Pixel Form. Due to the basically the let, let, let me check. I will show you. Uh, I use Ubuntu 19.0.4, 16.0.4 LTS on this device, and we can see here own form. Normally, tutorials, if compress, incompressible. Here is several software for incompressible like Pixel Form, CD, Pixel Form, and we can see that this software don't solve the temperature equation. I mean energy equation like that. Here is it in my thesis I do in France. It's wrong icon, and due to the incompressible software don't solve the temperature equation, so we want to modify to add them the equation to solve the temperature every once. So I will show you how to add the that equation to the software to get result. So firstly, we have in office I use the Rand's Rayleigh average Navier-Stokes equation. Yeah. After we solve the turbulence and the velocity pressure, we want to solve the energy equation. Here is the energy equation. I want to solve in transient flow, so I add the delta t great to delta t small. With delta t is the heat diffusivity of the air, with K is the air conductivity, Cp is the specific heat, and rho is the density of the air. So I will add this equation to the Pixel form, and I change that to that Pixel form to my Pixel form. So the software could solve the temperature for me. I will let you know how to do that. Firstly, we must copy the software Pixel form to this to this every files. So just copy to here and change the name. For example, I will go to the software Pixel form, right? CD application. Due to this open form is like a lot of software, not only one software, so we can modify software without any effect to another software. So it's really good. So go to software, go to incompressible Pixel form. Here is a Pixel form. And we have all the same thing. I just copy this, and you can go this and copy to here and change the name in Pixel form. So in this software we have several like created edge. My Pixel form, I change the Pixel form program to the Pixel form. So how to change in this, and then we copy the file to this, and we have here. So firstly we change the name of everything. Go to the make, change the file option, open and change the piece of form to my piece of form, like that, to execute the library to my piece of form. Save and the option. Also, don't change everything in this, just let them to export library to this folder and change this file to my piece of form. So you can change the name, everything you want, but I change this to my piece of form. Created edge, go open. I will show you how to get it. So we want to solve that equation like here. We must have the several things here. Firstly, we must have here to the constant value. So we push this value to the file. I will show you later how to push this value. And delta T is equal heat conductivity divided for Cp and rho. Alright. So this created field we reach. Firstly, we reach a match, and then reach the dimension dt. dt in the transport property in the file. I will show you how it look like in here. On form, you can go to the form run case for just for example, and you would go to the transport property here. No, not here. Transport property, look up for dt, and I add the dt in this, and you can see here dt, which dt is a 30° density, and I calculate this with dimension of this dt. So we add dt in this file, and the software we go this code we go to the transfer property to find the dt, to save it in the mesh, and read p, read u velocity, I mean this time scale, etc. And when they did read every boundary condition, they will really save this value to the center of the cells when calculation. All right. The next thing I want to show you here in the, let me check, the form application software and piece of form. Next thing I want to show you is in my piece of form. How to change that? We must add the T equation. T equation means the temperature energy equation here. It's basically is a divide for dt plus phi t and divide for Laplace t. It's represent for this equation, and you can get more when you read how to write the derivative equation in old form with this. Then we solve this t equation and solve this equation, and then write it to the mesh file. It's and you just here you solve the equation. Is this cos error represent for this equation? All right. And the next thing I want to show is in P equation. Everything is okay, right? P equation is solved for pressure, and U velocity equation, U equation is solved for velocity and the turbulence, etc. And then when everything we done, we go, and I just go out and go to the directory, solve this, and cd e cd mnt e form cd application cd server my pixel form. Here is a file I just modify, and then modify, then we just type word make, and then everything we done. Make. No. Oh, okay. Let me first, because I had do it previously, so I just delete the library of this. Let me check again. And you can go here and everything we done. Just I will make on form 6. Due to I use alias, so I must type on form 6 before I run every command in on form. So we'll make, and this will make me be generate the library to the will make regenerate library to the, and then when you type my pixel form, sorry, so form, and if you get this, it means you have been success, like that, you have been success. And I will try to run on the example case. Run case, for example, and cd const nano transport property, and you will see in the transport property I had add the dt to that, and Ctrl X for escape, and go to the system file, Ctrl X, nano, Ctrl X, and in the application I had start with my pixel form. Alright, so let's escape. Just type cd s block mesh, no cd system nano mesh disk. I want to reduce the mesh to get quicker simulation. Ten, and Ctrl O for override, and enter, and Ctrl X, cd block mesh, running. And if you want to see the mesh look like, you can go to the, nano, go to the form, dot form, just go to this, and you will see we have the form dot form here. So go to the parallel, and open this file. So this file will be read every mesh and case in it. Wait a little bit due to my computer is not run smoothly. Here you open the file I had shown you in the open form in the run case, and go here, click OK, and plus apply. Wait a little bit because it needs time to load. Here is the mesh I just created. Very close. Here. So I will run my pixel form on that. If I run pixel form, and so firstly I will run pixel form, and I have the mesh, I run pixel form, and you can see the difference, and it's running right. Reload file, release, open format form. In here I have several case, so I open that. So wait a little bit. Wait a little bit. Ctrl+C for stop, and then we have several case here, so just open that for C, and here I will see we don't have the NE, and I will run this for you. We don't have the temperature in here, just news and I center that. So I want to use different my pixel form for that. So firstly I will delete all clean for grammars or 0 1 plus for delete other, and then I will use my pixel form. You running right, and I will show you the difference. Here we don't have the temperature, but when I use my pixel form, the software will show temperature for me. Wait a little bit because I want to get results, beautiful result. Reload file, and now we have the temperature, right? See the temperature distribution. In this, I set the heat flux inside this wall, so the temperature start here. T, and we can reload file. Reload file. I use less turbulent model, so it's quite it look quite awkward, right? But when it goes smoothly, we will see the difference. Okay, let's delete that and open it. Open temperature, and I get 90, and you can see the developing of the temperature inside this. I also apply the velocity inside knot. Reload file. And you can see the temperature also fluctuated, right? Reload file. temperature distribution. Thank you for watching, and I hope you can get you can develop your own software in when you see this tutorial. And see you again next time.